This short video is to look at the difference between algebraic expressions and algebraic equations. Typically, questions of these two, with the expressions, a question will say to simplify the algebraic expressions, and the instructions with an equation will ask you to solve the algebraic equation. So the differences between these two are significant, and how we treat them and what we're trying to do with each of them is different. So first of all, when we're simplifying an algebraic expression, our final answer is still going to be an algebraic expression, and it may have more than one term. When we're solving an equation, our answer is going to be in the form of a variable equals some value, like x equals 7. When we're looking at algebraic expressions, each step should have all parts of the expression, and there should be an equal sign at the beginning of each step. When we're solving an equation, there should be an equal sign between the two sides of the equation. Again, there's still one equal sign for each step. When the two things have fractions, we treat them differently. With an algebraic expression, we can simplify the fraction, we can combine fractions by adding or subtracting using common denominators, but often we are unable to completely eliminate the fraction. In solving an algebraic equation, if we want to get rid of the fraction within the equation, we can do that by multiplying each side by our denominator to get rid of that fraction for that step. In the final step, we may still end up with a fraction, but we can do the steps in between without having to use fractions by using this method of eliminating the fraction. And lastly, how we check them is differently. When we're checking our simplification, we simply go over each step, make sure we haven't made any silly mistakes, as we all often do. But with solving an algebraic equation, we have a little more powerful of a check, because we can substitute that value that we get into our original equation and see if the left side equals the right side. So here's two example questions. They look very, very similar, but one is a simplify an expression question. The other is a solve an equation question. So with these two, how we solve them is a little bit differently. I'm going to go through the solve equation one first, actually, even though it's in the second column. So when we look at that solution, we can see we do have these fractions, and if we want to get rid of them, we can see the common denominator between 3, 4, and 2 is 12. So we can multiply each term in the equation by 12. Now when we do that, we can cancel each step. So 12 divided by 3, right? The 12 and the 3 cancel, leaving us with 4. 12 divided by 4, the 12 and the 4 cancel, leaving us with 3, and 12 divided by 2, the 12 and the 2 cancel, leaving us with 6. In the last term, they don't get canceled. Once we have those canceled, we can multiply, so we go 4 times 2x gives us 8x, 3 times 3 gives us 9, x times 6 gives us 6x. Then we can bring our like terms together, so we can subtract 6x from each side, so that it's eliminated on this side, and we can subtract 9 from each side, so it's eliminated on this side. So we end up with 8x minus 6x gives us 2x on the left side, and 12 minus 9 gives us 3 on the right side. So we're not completely done till x is completely alone, so we divide both sides by 2 in this case. So we get x equals 3/2, or 1.5. And we can check our answer on those ones. So remember we said whatever our result is, we check by putting that into our original expression. So our original expression looks like this. So wherever we've got an x, we're going to replace that with 3 halves. So we're going to get 2 times 3 halves over here. And on this fraction, we're going to get 3 halves over 2. So then we can do our usual simplification here. So the 2 and the 2 cancel. So we end up with 3 over 3. For the other side, when we're looking at what we're doing, right, 3 halves divided by 2 is the same as 3 halves times 1 half. You'll notice I've color coded this because you could do all of the blue, figure out that answer, and then do all of the purple, figure out that answer. So here we can simplify. 3 over 3 is 1, and here we get 3/4. And so on both sides we end up with 1 3/4. So our left side equals our right side. So the final answer that we thought we had from our solution, whoops, went a little too far, that x equals 3 halves is correct. So we can identify that answer. Looking at the other one, simplifying our expression, we can't get rid of the fractions because we have no equals. We have no other side to multiply by. But we can use common denominators to combine like terms. So our x's are like terms, and they have 3 and 2 as their denominators. So 6 is going to be the common denominator. And our constants, 3/4 and 1, are like terms. So we need to get them a common denominator of 4. So this one here, we need to multiply by 2, top and bottom, to get 6. So remember, when we're getting a common denominator, we multiply numerator denominator by the same value. So the first term multiplied by 2, the third term multiplied by 3, that will give our x's both a denominator of 6. You'll notice I also put these two parts together, right? So first term and third term became first term and second term. And then likewise with my constants, I already had a quarter here, but I multiply top and bottom on my other constant, because remember we can put 1 as 1 over 1, and so we get 4 over 4. So 4x plus 3x all over 6 gives us 7x over 6, 7x over 6, and 3 plus 4 all over 4 gives us 7 over 4. So our final answer here is just going to be this whole expression. So we can check our answer by checking over each step, but it's not like in the other one where we can take our answer and substitute it into something and see if it works out to a final solution. So there's our major differences between simplifying an expression and solving an equation.